Hi, everybody. I didn't mean to make you wait. Hi, I am 3D printing obsessed. I'm not 3D printing obsessed. I'm just excited because I'm wheeling 3D printing finally into the process of this shop. And I've got a new Kobra Max, Anycubic Kobra Max for large volume printing. It's slow, but it's big. It's giant. And that's what I'll be printing space helmets out of. And I've got a couple of BambuLab Carbon X1s, which are just phenomenal speed demon workhorses extraordinaire. The Anycubic Kobra, actually, let's go talk about it. Why talk about it in the abstract when it's right here printing for us? This is my first print on it. Technically, it's the second print. This is a neck ring. The first print was the owl that came with the SD card. So this is an 18-hour print. It's about 4 hours in. Come back tomorrow morning and see how it did. But as you see, the difference between this printer and the Carbon X1, which is also printing. The big difference between them is that the Kobra Max does not have an enclosure. And it does fine without the enclosure, but it'll do better with the enclosure. So I have bought enough 1/4-inch acrylic from Tap Plastics to house this thing. That's tomorrow. But right now, as you see the filaments out here hanging out in the open, it's going commando. And I'd like to put it into a box with some desiccant in it. So I'm going to build a little dry box for it. And the way I'm going to do that is I'm actually going to install that dry box down here. The goal is the dry box lives here and that the filament runs out through PTFE into here and that I'm able to encase this whole thing. And then also I lower its side-to-side footprint and get rid of this thing. But I'll make the enclosure tomorrow once it's done printing. Isn't this great? Look at this, all of this 3D printing area. That was today's one-day build. That was yesterday's. I didn't even film that. Sorry about that. And so now we're going to make this dry box out of some acrylic that I have lying around. Not entirely true that I had it lying around. I actually picked it up expressly for this purpose. I want to make this accommodate a 3-kilogram spool, which are just over 4 inches in thickness and 11 plus in diameter. Now, the question is, what can I get out of this sheet of stuff that I've got? So this is 24, I'm guessing. Yep. All right, so I'm not going to get more than, I suppose I could. I cut a chunk off if I wanted. So is this more than 24? It is. Is it more than 5? It is. Yeah, that'll be easier. I'll make it a slide-out door, a side opening door that slides out. It'll have a bit of acrylic here for the spool. So I want it to slide out. I need 4 inches and 1/8 for the width of the spool, plus 1/2 inch for the thickness of this. So that's basically 5. And then I want room. So let's say 6 inches. 11. I'm going to go 12 and a half and 12 and a half. That gives me 1/2 inch of leeway around the whole perimeter of this thing. Okay, so 2 12 and a half inch squares. We're almost done here. And please know that I'm not following any really specific hard best practices with the acrylic. I'm using Weld-On 16, which gives me some wiggle room. This thing won't reach full strength for a couple of days. Actually, it's not a couple of days, maybe a few hours. But, and so now I'm working out the door. And instead of hinges, I've gone with just, is this the same both ways? It is. Great, look at that. So then I can put a little bit of a noodle nudnik there. Actually, let me soften that. If I was making like a vivarium for a lizard, I'd be following much different practices. If I was making something watertight, but I don't need it watertight. I just need it somewhat confining of air is truly what I need. So it will sit like this, and it will sit like that. Oh, whoops. Duh. Good God. I am my own worst enemy. Let's just let that sit and I'll stop mucking around with it for a minute. All right, the box is most of the way there. Here's what I want to do. I want the filament to come out of here. So it'd come in the center here. It'll probably come sort of high right around there is my guess. And if I get this wrong, I can just plug it. But it doesn't strike me that the pull of the PTFE is very exact, the location it pulls from. So we're gonna just a little bit of pressure. There we go. And then this will feed out of here. Like this. Yeah, see? Then there she blows. And now that's not so bad. Yeah, that's pretty good. All right, now I want to make a little bit of a shelf for this thing. Oh, dirt! Oh my God, I did the same exact thing. Here we go. This is me thinking about dinner, thinking about going home. All right, so here's how the shelf is gonna go. It's all gonna be very quick. Hold on, I'm just gonna text my wife. Right, let's go. All right. I have soft placed the shelf back here where it's going to go. It's going to feed up that way. So I'm really happy with how it looks. I'm just going to pop it in with a little bit of actually, no, those guys. Technically, it should only take one screw on each side. There we go. Yeah, that's not going anywhere. These can go back. And this lives here. And when one wants access to it, one opens it up, swaps it out. Pops it back in. This comes up and around here. Yeah. Tomorrow morning, I'll get this thing printing so you get to see it all in action. I find myself wondering if I don't want to put a light up under there, but I don't want to put a light up under there. I don't know. But all the printers are going. All the things are in place. The systems are burning in. It's very exciting. Thanks for joining me for this. I wonder if I couldn't just... Is there any reason I couldn't run a vacuum hose from here into there? Like on this here, like on the side of this box here, a vacuum hose that goes from here into this box, which is already being, right? I mean, this box is, it's a little warm. It's got air circulation. I don't know. I'm gonna have to research and maybe I find a smaller dehumidifier or something like that, like a lizard heater or something like that. We'll see. Oh, I love it. I love all the infrastructure. I love infrastructure for creation. It's fun stuff. All right, I decided I could add a light. Let's add a light. Let's add a light. Yep, there we go. Excellent. Lovely. Lights on everything. Thanks for joining me for this one day build. I'll see you guys next time. This printer is great. It has great reviews. I printed up a neck ring last night for a space helmet and it's lovely. It will print better if it is enclosed. Now, I went online and I looked at enclosures for this and they're expensive, like $1,100 expensive. And I was like, what? That's crazy money. I will order the plastic and I will build my own. And here's what I want to tell you. That's $600 worth of plastic. Look, I bought this from Tap Plastics, not the cheapest purveyor of acrylic, and I paid per cut. I drew out the cabinet I want for my Kobra, and I gave the part size breakdowns, the sheet size breakdowns, to Tap Plastics, and so they did this as a custom cut out of custom sheets. So you can get out cheaper. You can buy 4x8s. If you have a big shop, you can buy 4x8s of 1/4-inch acrylic for probably a lot less and cut it to your own size. I don't have a shop big enough. I really can't cut 4x8s in here. I cannot. So I got to farm that out. Anyway, it's an expensive proposition no matter what. And there are cloth solutions. There are like, as long as you are apparently like limiting airflow and allowing the environment around the print to be stable, there are all sorts of mitigations that work, including like a cloth type enclosure. But I wanted to be able to see the thing. I want to, of course, I'm going to put lights in it. Also, I've got to be able to monitor it remotely. I want to put a camera on it, all of these things. So we're going to build an enclosure for this today. Now, I've already started. And the way this enclosure will work is there will be a base that is like a long tray. And then the 5-sided box that sits over the Kobra will sit in that tray. So it's very easy to remove the enclosure, to have access to the machine, but it will sit on there, and that'll be that'll be good. And then I'm actually going to cut a door in the front of this. What I'm printing here are some 3D printed hinges to go with the door here. I think that's everything to cover right now. Oh, right. The tray, I already built the tray this morning, made out of 1/4-inch acrylic glued together with Weld-On 16. That is, oh, whoops, I left the cap off. That's terrible. Weld-On 16, this stuff. It's absolutely fabulous for gluing acrylic. It is not going to give you the... Acrylic gluing is... You're never going to quite do it as good as they do it at TAP. But that's because it's a whole shop dedicated to do one thing, and it does it really, really well. I am willing to tolerate lower quality constructions for my stuff, but this is the main tray. You see how big the build volume is on this thing? It's absolutely gigantic. So it's not this big, but the case needs to be this big to accommodate that whole build volume. I did this first because I wanted it to be more solid when I put it. It's the more delicate of the pieces that I'm working on today because it's flippy floppy. Yeah, but it should be fine. Ooh, static. I am going to install the platform on the underside here. Hold this, put it down. Yep, there we go. Let's get this back. Hey. So I've got it on its platform here. It's big. It's a big thing, but it's prepped. I'm not sure I'm going to send a print once Norm sends it to me, and then I'm going to build the cabinet that goes on top of that. Meanwhile, the Bamboo is steadily printing some hinges for me. So first up is the front door. This is up, and I want to cut this out. Is what I want to do with the jigsaw. I want to cut out a door here, and it is like. A radius on those. I want to cut this door out before I assemble the box because I don't want to cut it out after the box is assembled. That's going to be a pain in the butt. I'm just going to take a look at this in here. 31, that's 15 and a half. At any rate, I can drill a hole here and use that for my starch. No, I don't love that blade. All right, I'm kind of happy with that. That's the door, and that's the door frame. Yeah, nice. This edge, once I get 2 of these glued down, then I'm in pretty good shape. That is the top. Yeah. Okay. That seems pretty freaking good. That. So let's let that sit like that. Okay, come on. All right. Oh, darn it. Can't fix the camera. Sorry about that. The camera fell. All right, box is glued up. I'm going to cut out another part of the door. Actually, I can't do anything until I remove this box. I can't cut out the other part of the door until this moves. So we're just going to pause for a minute. It is universally accepted truth of the YouTubes that when you go to set up something elaborate to film, you'll forget to press record, as I just did. Count Spatula here, Sean Charlesworth, just helped me put the case on here, and then we peeled off all the blue like it was like Christmas morning, and I didn't cover any of it. But the printer is still printing. And now once I get this door on, it'll be a nice enclosure and we'll get the hygrometer in there. I'm sorry that you missed the exciting part. I know, it's kind of hard to see. It's like Wonder Woman's jet. Okay, I'm really sorry about not recording that last part, so I thought I'd show you how I'm going to light this thing. I simply have here a piece of hardware store C channel. That is 5/8 by 1/2 inch. With some VHB stickum on the back and some LEDs in the front. I'm going to stick that to the roof inside here and route it out to the same power supply that's lighting everything else here. So you should be able to get to see it all light up. Right, we got to peel off this business first. Okay, here we go. Route this in here. Peel this. Place this. Here. Oh yeah, that's good. There it is. Sorry, come on in. There you go, all lit up. So I got some work done on the door. Here is the door. This is the cutout. And then I cut out a second piece to be a surround, and that'll allow me an airtight fitting. I was 3D printing some hinges, and I printed up these, which are lovely print-in-place hinges, but I didn't feel like they were sturdy enough to hold up this big door. It's heavy. It's very heavy. I'm not going to trust it to hold up this door. I'm going to use this piano hinge, coffin hinge. But I'm about to rivet in my keeper. This will be the piece that glues to the stand itself and holds it up. So I'm just about to rivet that in. All right, I'm using rivets on this acrylic because it's just nice and fast. And you know me, I love a mechanical connection. Right. Now my method for attaching this to the thing is actually Yeah, I'm going to go there. It's bold. It's a bold method. I'm going to run some glue up here and I'm going to sock this on and tape it to the door so that the next time I undo that tape, it'll be to open this door and it'll hang off this thing. Like the print in there is going to last for days. Oh, wait, I may want to do one thing. Hold on. All right. So, I cut this inner piece out of the frame I'm installing it back into, which means I've got a saw kerf, the thickness of my saw blade, top and bottom. If I just pop this in, it's going to sit on the bottom, and I don't want it to. So I cut this piece of styrene, which is pretty close to the kerf of the blade, about 40 thousandths. Actually, is that? No, it's actually about 60 thousandths. Still, we're right in the zone. And I will put this at the bottom of the door frame, sit this on top of it, then tape it in, and then I'm going to put some glue on here, sock it in, and the next time I open the door, it should hold itself up. Oh, one last thing. I'm actually going to install 2 long rivets. Yeah, I am also going to install 2 long rivets. So I'm going to drill those just to help with the mechanical holding of this thing. So there's one aspect of the design that I hadn't thought all the way through, which is how much weight this door causes on this whole thing out here. And it's a lot. It's a lot of weight. And it's all sitting on this tray. So I am going to add in a pair of triangular gussets here that are going to sit here and support this. Yeah. I'm going to do it like that and then pivot it into there. And yeah, this should give me the extra support that I'm hoping for this. Because this is on the inside of both ends of the door, this is bearing all the weight I need. I don't need to run a stringer in between them, I don't think. So let's get these guys going. Great, nice and flat across. The other one. Oh, wow, I don't have the, oh, I guess I can move it. Yeah. All right. This is hard to drill with your left hand. All right. Hopefully that doesn't impart any stuff to our print. Now I'm going to install this piece of styrene as a spacer on the underside of the door to better allow the insert door to find its way. That's great. All right, so that is being properly held in here. Let's get some extra help. Good. It's I want, when you're doing something mechanically like this, I want it touching mechanically all the way around the edge. If you don't set something up exactly how you want it and then you drill holes to secure it, you can secure it in its cattywampus sort of orientation, and that, well, that's no good for anyone. Right, drill. So here we are. This is our hinge. And what I'm going to do now, And I've got mechanical contact all the way around the perimeter here. I'm going to glue. I'm going to put some glue over here all the way down. And then I'm going to close it. And then once it's closed, I'm going to come in with a rivet gun and pop those 2 rivets, and that should hold this all quite nicely. Plus, yeah, this is great. This is really great. Okay, here we go, closing it up. Yeah, great rivets. That's wonderful. Okay, let's do one more hole. Okay, here we go. One right in the middle here. Good. All right. This one's done. Nice. Soon we'll be putting on the lock. Yes. Oh, opening up and closing again. Dude, swings shut. There she blows. A new container. Super pleased with the closure itself printed. I'm really happy. I don't know how many videos this is going to be, but however many builds were encompassed in this video, thank you for joining me on them. Look at that, 39% humidity. The inside of this is exactly where it should be humidity-wise. All right. My other carbon arrives later. God, literally, it's going to arrive in minutes, you know, like less than an hour. Matter Hackers, the local distributor for the X1, Carbon X1, has sent me one of these. Now I've finally got my second carbon, and it's time to install it here onto the rack built for a pair of carbons. Last night, I even printed up a poop chute for the back of the carbon. When the carbon is cleaning its nozzle, there's a little chute at the back of the machine where it just like gets rid of, literally, it's like a chute. It's called the poop chute. And I've got a basket there. My hot box is working beautifully. It's keeping it at 40% humidity. This morning I built the enclosure for the Anycubic, and everything is great. Everything is super great. So I thought I would just film the unboxing of this business. I thought we would film the unboxing of this business, and then we would send some prints. Yeah. this upside down? It is. Well, it does say side up. Here's hoping that this arrived nonetheless. So they actually do this really lovely thing about pulling it out is the bag itself, the sides pull up on the flaps and you are meant to pull the spool thing out. How freaking cool is that? That's some sample PLA. I know I unwrapped one of these a couple of weeks ago, but I always do that. This is the glass top, and that one's not broken. Like that. The interface screen. Stick here, hot end. Use Allen key to remove the screws as quickly. Oh, right. Forgot about that. There she is. That's the AMS. All right. Now this is literally only for holding the AMS in for shipping. Oh, right. And plug this in. There she blows. Everybody's on. There are two desiccant holders in the AMS, which are meant to keep your stuff dry. There we go. That's in. Here we go. This is exciting. Adding a printer. Thank you guys for joining me. I will see you next time.